Good morning, everyone. So, myself Suresh, a lecturer in mechanical engineering. So, I am going to deal with a subject called basic workshop technology. In that, I chosen a topic from a carpentry. So, today we are going to discuss about some of the tools used in carpentry. As we all know that in previous class we discussed about the marking and measuring tools. Among that, so today also we discuss some of the tools used in carpentry. So those are cutting tools like saws, chisels and plates. Okay, so we discuss about cutting tools like saws, chisels and plates. Okay, and also some of the specifications and the uses. Okay, so that is for saws, chisels and planes. How the what are the specifications of saws and how they are using, and also specifications of chisels and the usage, and how we are specifying the planes and the usage of planes. Okay, now we discuss about the some of the cutting tools used in carpentry. Okay, basically the cutting tools are used to cut the wood to appropriate size or shape. Okay, and to cut the excess wood to get desired shape, size and accuracy. So first of all you have to take a wood piece, and whatever the dimensions we required, first of all you have to mark on that workpiece. Then by choosing some cutting tools, so we can remove an excess material or some excess woodwork piece to get the desired shape and size to an higher accuracy, or to a required accuracy. Okay, so cutting tools are classified as saws, chisels, axes, planes. Okay, so now we discuss about the first one, that is saws. Okay, saws or hand saws. So now we can see the figure here. So there is a figure on the left side. So we can see the, for the left figure we have different parts. So we can observe the figure. So there are different parts. So they are toe, heel, back, nib. Okay, so we can see, and also there is a handle here. So here it is not mentioned, but so here we are using a wooden handle. Okay, so this type of saws are known as hand saws. Okay, now we can see here. So this saw is used for cutting the wood to obtain a desired shape and size. So whatever the size we require, okay, so to get that required shape, so here we are using the this hand saws. Okay, next, so we can see the parts of hand saw. Wooden handle, as I said earlier. Blade carries cutting teeth. Here we can see, for the right side figure we can see the top figure. So there we can observe the blade which carries teeth, cutting teeth. Okay, next we can see the saw teeth setting. Okay, how the saw teeth settings you can see here. All the cutting teeth are set to the right or left of the blade alternately to make the width of cut wider and to move smoothly across the wood. Okay, so what is saying here? All the cutting teeth are said to be either right and left, not right or left, right and left of the blade. Okay, alternatively. So to make the width of cut wider and to move smoothly across the wood. Next we can see the specifications for the saw. So we can see the specifications for hand saw. Okay, so hand saw is specified by a length of the blade, so which is varies from 600 mm to 700 mm. Okay, next second one, pitch of the teeth. Okay, so which is varies from 2.5 mm to 8 mm. That will be the pitch of the teeth for the hand saw. So based on these two specifications, okay, so we can select or specify the saws. Now we can see the, so what are the different types of hand saws. Okay, let we know the first one is, that is a rip saw, second one cross cut saw, okay, third panel saw, fourth tenon saw, fifth dovetail saw, sixth bow saw, seventh coping saw, eighth compass. Okay, so and the next one is pad or keyhole saw. Okay, so all these are the different types of saws we have. Okay, so first we discuss about the rib saw. What is a rib saw? Here we can see the diagram of a rib saw. Okay, we can see here, right? So rib saw is used for cutting the wood along the grains. Okay, so this rib saw is used for cutting the wood piece, so along the grains, and this cutting process is known as ripping. Okay, the process of cutting this is known as ripping. So by using rip saw, so we can cut the wood piece along the grains. Okay, next, so its teeth have chisel edge. So how will it looks like, how will teeth will looks like? So it's look like a chisel edge. The teeth have chisel edge, and the pitch ranges, that is the pitch of the teeth, which is ranges from 5 mm to 8 mm. Okay, what will be the pitch of the teeth? That is 5 to 8 mm. Okay, and the length of the blade is about 700 mm. Okay, for rib saw. Next we can see the cross cut saw. We can see the diagram here. Okay, so if you observe the previous diagram, rib saw and cross cut saw, we can observe the figure here. This is the rib saw, and next we can see the cross cut saw. Okay, so you can observe the figure here, cross cut saw, how we are placing the workpiece, either along the grains or not. Okay, or across the grains, we can see here. Okay, so as per the figure given here, so here it is across the grains, not the along the grains. So the cutting in across the grains, that we can see here, right? So this cross cut saw is used for cutting the wood across the grains. So previously for rib saw, so we can see that the cutting the wood along the grains, but here in cross cut saw, the cutting the wood across the grains, not the along the grains. So across the grains, the teeth are pointed. Okay, it's not like a chiseled edge, but the teeth are pointed. The pitch of the teeth is about 2.5 mm to 3 mm. 2.5 to 3 mm, that will be the pitch of the teeth. Okay, next, length of the teeth, you can see here. Okay, that is about 600 mm. Okay, sorry, length of the blade is about 600 mm. Okay, so per centimeter how many teeth are there? You can see here 3 to 4 teeth per centimeter for 1 per centimeter. So here we have 3 to 4 teeth. Okay, next, third one is, that is a panel saw. So this is the diagram of a panel saw, you can see here. So panel saw diagram. Okay, so this panel saw is commonly used hand saw. So this is a generally used hand saw. Okay, so it is almost similar to crosscut saw and used for finer works like door panels, plywood sawing. Okay, and also used for cutting along the grains as well as across the grains. Okay, so we can also use this panel saw for cutting the wood along the grains as well as the across the grains. In both the cases we can use. Okay, that is panel saw. Next, we can see the pitch of the teeth. The pitch of the teeth of the panel saw is about 2 mm to 2.5 mm. Okay, that will be the pitch of the teeth, that is 2 to 2.5 mm. Okay, next, teeth per centimeter. How many teeth per centimeter? That is 5 to 8 mm. 5 to 8 teeth per mm per centimeter. Next, we can see the length of the blade. Length of the panel saw blade, that is about 700 mm. Okay, next we can see the diagram of a tenon saw. Okay, tenon saw diagram. So tenon saw, the blade has brass or steel. Okay, for the tenon saw, the blade has brass or steel back reinforcement which protects from bending during the straight cuts. Okay, next, it is used for cutting small works like joints. Okay, next, length of the blade, that is 250 mm to 400 mm. That will be the length of the tenon saw blade. Okay, that is 250 mm to 400 mm. Okay, next, width of the blade. So for this one, so they will have a width of the blade. Okay, that is 60 mm to 100 mm and 6 to 8 mm. Okay, that will be the width of the blade. Next saw is dovetail saw. Okay, now we can see the diagram of a dovetail saw. Okay, right, so it is similar to tenon saw, but the size is small. Okay, so This dowel saw is similar to the tenon saw, but the size of this saw is smaller in size. Okay. Next, the blade is fitted to the open handle. Here we can see the blade of the saw is fitted to the open handle, not a closed handle. So totally it will be a open handle. Okay. Next, so this dowel saw is used for finer works. Simply we can say a tough or smoothly works, like finishing works. Okay, so it is used for finer work like tongs. Okay, like tongs for dovetail joints. So we have different types of carpentry joints. So among the dovetail joint is the one of the joint. Okay, if you okay, this dovetail saw is used for the finer works like tongues for dovetail joints, cabinet works. Next we have a length of the blade, so which is ranges from 200 mm to 300 mm. Okay, that will be the length of the dovetail saw blade length. Okay, that is 200 mm to 300 mm. Okay, next pitch of the blade. So dovetail saw pitch of the blade, which is ranges from 1.25 mm to 1.75 mm. Okay, so the pitch is small, very small, that is 1.25 mm to 1.75 mm, and 60th per centimeter. So per centimeter, so we have 6 teeth. Okay, next, so next one will be a bow saw. You can see the diagram here. So this bow saw is little bit different from other saws. Okay, you can see the diagram here, right? So this bow saw is used for cutting curves, profiles or irregular shapes. Suppose if we want to cut the curves or profiles or irregular shapes, simply we can say that some French curves. So at that time we are preferring for the bow saw. Okay, next, the blade is connected between two handles. So here the blade is connected between two handles of wooden frame. So this will be the wooden frame. So for this blade, so here we have two handles. Okay, so for these two handles the blade is connected. Next, so tension to the blade. Okay, so tension to the blade is provided by twisting the string. Okay, by twisting the string with a lever at the upper end of the frame, so we can develop a tension to the blade. Next, so length of the blade. So we can observe the figure here. So it is a little bit difficult. Okay, so for this blade, the blade length is about 300 mm. That will be length of the blade. And the next is pitch of the teeth or teeth pitch, that is 2.5 mm. Okay, this will be the pitch of the teeth, 2.5 mm. And the next one is, we can see the diagram here, that is a coping saw. Okay, so coping saw we can see. So there are parts for the coping saw, that is frame, handle and a blade. So handle is made up of wood. Okay, handle is made up of wood, that is wooden handle. So this coping saw is used for cutting excess wood, small curves to make dovetail joints. So whenever we require dovetail joints, so we can at that time we can prefer for the coping saw, so which is used for cutting excess wood. Okay, that is nothing but we have to remove the unwanted wood metal, okay, and prepare a small curves to make the dovetail joints. So the blade has a small pin on each end. So the blade has a small pin at each end, so which fits into the slotted lugs in the frame. Okay, so the blade has a small pin on each end. Okay, so which fits into the slotted lugs in the frame. Okay, that will be the coping saw. Next we can see the tension to the blade is adjusted by screw handle. Okay, the tension to the blade is adjusted by screwed handle. The length of the blade is about 160 mm. So that will be the length of the blade, that is 160 mm. Next we have a width for the coping saw. So coping saw blade width is of about 3 mm, that is nothing but 3 millimeters. Next we can see the pitch of the teeth. So pitch of the teeth that varies from 1.5 mm to 1.75 mm. So that will be the pitch of the teeth. So that is 1.5 mm to 1.75 mm. Okay. Next we can see the another one here, that is keyhole saw. So there is another saw, that is keyhole saw. You can see the diagram here. Okay, this is a diagram of a keyhole saw. So this is a smallest saw and used for internal intricate works and keyholes. So what is the purpose of usage of this keyhole saw? So this is used for internal, okay, internal works and also for intricate works and also for keyholes. Okay, next, so tapered blade. So how will be the blade? Tapered blade, okay, which is fitted into the metallic or wooden handle. Okay, the handle may be either metallic or wooden. Okay, so for the wooden or metallic handle, the tapered blade is inserted or fitted, so by means of a screws. So by means of screws, the tapered blade is fitted into the either metallic or wooden handle. Okay, next, the handle is made hollow. Okay, how the handle will be? So the handle is made hollow from inside and the length of the blade can be adjusted. Okay, next, so next, length of the blade is about 150 mm to 200 mm. That will be the length of the blade. Next is width, that is 6 mm near handle. Okay, that will be the width of the blade 6 mm near handle and 3 mm at tip. So that's why we can say that it is a tapered blade. Okay, at the tip of the blade, that is width of the tip is 3 mm, and at the nearby handle the width is about 6 mm. Next, pitch of the teeth. Okay, that is pitch of the teeth is about 2.5 mm. That will be the pitch of the teeth. Next, we can see the another one here, that is a compass saw. Okay, compass saw. We can see the diagram here. Okay, you can go through the diagram here. You can observe the diagram here. Okay, so this compass saw is used for cutting straight or curves in a limited space. Okay, in a limited space, so this compass saw can be used. It is used for cutting a straight or curved curves. Okay, it is used for cutting the straight or curves within the limited space. So outside or inside the woodwork. Okay, so whatever may be, either inside or outside the woodwork, so we can cut the straight or curves. Okay, next, for internal cutting. Okay, for internal cutting, cutting a hole is drilled first. First of all, what you have to do, we have to make a hole on the wooden workpiece. Okay, for internal cutting. Next, and then the blade is inserted into the hole. Okay, so first one, you have to already you have to select a existed hole on the wooden workpiece. So if you want to increase the or smoothen the internal surface of the hole, so we can use this compass saw. Next, the blade is fitted to the open handle. So for this type of saw, so the cutting blade is fitted to the open handle. Okay, next, the length of the blade. The length of the blade is about 250 mm to 250 meters to, so not 250 meters, it will be 250 mm to 400 mm. 250, that is very small, no? That we can see, that is 250 meters to 400 meters. Next, we can see here width of this compass saw. So that is about 50 mm at the handle. At the nearby handle, the width of the blade is about 50 mm. Okay, and 25 mm at the tip. Okay, so it is also a tapered blade. So at the tip of the blade, the width is about 25 mm, and the nearby the handle, it will be double the tip, that is 50 mm. Next topic is for next topic is chisels. So now we can go through the topic called chisel. So now we can see the diagram here. Okay, we can see the diagram here. Okay, so this will be the diagram of chisels. What are the chisels, how they are using, how they are specifying. Now we can see. Okay, right. So chisels are used for cutting excess wood so as to produce a desired shapes, joints and cavities. So what is the purpose of these chisels? These chisels are used for cutting or remove unwanted material from the wooden workpiece so that we can produce the desired shapes, joints and cavities. Next, we can see the parts of chisels. Okay, So parts of chisels. First one is handle. So we can observe both the figures. Okay, handle. Next, blade. Okay, in second figure we can see the blade. Next, brass ferrule. In the first figure we can see the part, that is brass ferrule. Next, tang. Just bottom of the brass ferrule there is a part called tang. Next, bottom of the tang, that is there will be a shoulder. Next, below that, neck. And the last one, bottom one, is cutting edge. From the top to bottom, so we got all the parts. Now we can see the specifications of chisels. How these chisels are specified, we can see here. The chisels are specified based on the size and by the width and length of the blade. So the size of the chisel is specified based on the width and length of the blade. Okay, that is the first specification. And the next will be the length of the blade, so which is about 125 mm. So what will be the chisel length blade length, that is 125 mm. Next, width of the chisel, that is 3 mm to 50 mm. Okay, that will be the width of the blade. Next, we can see the a topic called types of chisels. Okay, so we can see here, first one is firmer chisel. Second, beveled edge firmer chisel. We can also call it as dovetail chisel. Okay, the third one is mortise chisel. The third one is mortise chisel. Fourth, socket chisel and gauges. Okay, next, first we can discuss about the firmer chisel. Okay, let's we can see here. So this is a diagram of a firmer chisel, right? So this firmer chisel, okay, so it is capable of doing heavy work. So what is the purpose of this firmer chisel? So it has a capable of doing heavy work. Okay, so that is, it is used for joints and shaping the work. Okay, so by removing the unwanted material from the wooden piece, so we can make different shapes. Okay, and the next we can see the blade is of a rectangular section with beveled edge. So how will be the blade of the chisel? So it will be in a rectangular section. Okay, so with beveled edge. The edge of this firmer chisel is at like a bevel. Next, that this will be the length of the blade. The length of the blade of the firmer chisel is 125 mm. Next, we can see the width of the blade. So width of the blade is 3 mm to 50 mm, 50 mm. Okay, this will be the width of the blade width, 3 to 50 mm. And the next we can see here, beveled edge firmer chisel. We can see the diagram here. So we can observe the diagram here. For the three sides, right side, left side, and the edge of the chisel, we can see. So this looks like a bevel. Okay, so it is similar to a firmer chisel. So how it looks like? It is similar to a firmer chisel. The sides are beveled. Okay, the sides are beveled. So this is used to cut sharp corners. Suppose if you want to make corners very sharply, so we can use this type of chisel, that is bevel edge firmer chisel. Next, it is used for cutting sockets and dovetails. Okay, this is used for cutting sockets and dovetails. So next is the length of the blade. So is about 125 mm. This will be the length of the beveled edge firmer chisel blade. Next, width of the blade is as same as that of previous one, that is beveled edge, that is of 3 to 50 mm, 3 mm to 50 mm. Okay, as the same case of previous one. Next one is mortise chisel. Okay, so next topic is a mortise chisel. So this will be the next one, next chisel. So here we can see the diagram of a mortise chisel. Right, so this will be a robust and can take heavy blows and deep cuts. So where we can use this type of chisels, so whenever we can give a heavy blow on this, okay, and we require deep cuts. Whenever we require deep cuts, at that time we can prefer for this type of chisel, that is mortise chisel. So it will be a robust. Okay, next, so thick stock and narrow cutting edges. Okay, so how will be the cutting edges? So they are narrow and the stock is thick stock. Next, it is, that is mortise chisel is used for cutting mortises. Okay, so this chisel is used for cutting mortises. So width of the mortise is the width of the blade. So whatever the width of the blade is there, the width of the mortise is also same, that is width of the mortise is the width of the blade. Next, width of the blade, that is 6 mm to 13 mm, 6 mm to 13 mm, that will be the width of the blade. Next we can see the socket chisel. Okay, so this will be the another type of chisel. Okay, so that is socket chisel. You can observe the figure here. Okay, so here there is a handle, blade. So between the blade and the handle, so there will be a socket. Okay, we are placing a socket between the blade and the handle. What is the purpose of this socket? We discuss here. Okay, so it is provided with socket instead of a tang. Okay, so how we are fixing the blade to the handle in previous cases, that is in firmer chisels and different types of firmer chisels. So we are inserting the tang into the handle hole, but here we are not inserting any tang. So instead of tang, here it is provided with a socket. Okay, so this is used to remove heavy stock. Okay, so this socket chisel is used to remove heavy stock. Next, wooden handle is inserted into socket, so to prevent the splitting due to heavy blows. So whenever we are giving heavy blows on the chisel, okay, so what is happening in some cases, so it is going to be break. So for to prevent that one, okay, so we can see here what is happening here. So wooden handle is inserted into the socket. Okay, so what is happening here? The wooden handle is inserting into the socket so that we can prevent the splitting. Okay, prevent from splitting due to the heavy blows. Okay, next, blade is like firmer or mortise chisel. So how it looks? The blade looks like firmer chisel or like mortise chisel. Okay, so next one is, we can see here, inside gauge and outside gauge. Okay, so next topic is gauges. So you can see here we have two types of gauges, that is inside and outside. Okay, so you can see here a hollow curved plates. So these two are the hollow curved plates. So these are used for finishing curved surfaces. So these inside gauge and outside gauge are used for finishing curved surfaces of the workpiece and also known as round chisels. So these are also known as round chisels. Next we can see types of gauges. Outside gauge, okay, and the gauge beveled on the side, that is firmer gauge. Next, inside gauge, gauge beveled in the inside, okay, that is scribbing gauge, scribbing gauge. Okay, so this is the completion of this topics. Okay, I will stop here. Okay.